Welcome back, students. In this class, we would be studying about transpose. Now, if you were to be asked to obtain the transpose of a certain matrix, A, B, C, E, F, G, order of this matrix is 2 rows and 3 columns. Now, the transpose of A would be, remember, the rows that you see here would be converted into columns. In other words, rows change to form columns. So A, B, C would become a column now, written as A, B, C. Similarly, E, F, G, the row, would also become a column now, giving us E, F, G in this fashion. So now the order of this transpose matrix is, so this is what is called as transpose of a matrix. Now we are going to be looking into certain properties of transpose. Now the first property, it says that if you were to perform the transpose operation multiple times on a matrix, you will get the original matrix back. Now let us try that example. So let A be equal to, imagine 1, 2, 3, 4, -1 and 2. We are performing the transpose for this matrix, so that would give us, remember, the rows that you have seen here would become columns. So the first row is 1, 2, 3 would become 1, 2, 3 column. The second row 4, -1, 2 would become the second column 4, -1 and 2. Now we are going to be applying the transpose to this transposed matrix. So that would now become, now remember I have told you the rows that you see would become columns. So the first row is 1, 4. That would become 1, 4 column. The second row 2, -1 would also become a column. So that's going to be 2, -1. The third row 3, 2 would also become a column. 3, 2. So clearly this is nothing but the matrix that we started with. A transpose, the old transpose, would result in giving back the original matrix A. We would be seeing property number 2, which is K times A, the old transpose, would give us K times A transpose. Now K is a scalar, so let us just check this result out using an example. So what I'm going to do is I'm going to take A to be as a 2 by 2 matrix, say 1, 2, -1 and 3. Let me assume A to be some scalar value, say pi. So now let me consider the left hand side. So foremost, I need to find what is K times A. In this case, it's going to be pi times A, which can be rewritten as pi times 1, 2, -1, 3. So now rewriting it, I would have pi, 2 pi, -pi and 3 pi. So this has to be transposed. Therefore, K times A, the old transpose, would be, now in this case, we are left now to check the right hand side. So we would be considering the right hand side now, which is K times A transpose. This is going to be K times, if we were to take the transpose of the matrix A, let me show you that here. So matrix A is given to be as 1, 2, -1 and 3. I'm taking A transpose of this matrix, so that would mean the row would become column. So we would now have 1, 2 as the first column, -1 and 3 as the second column. So K times matrix A transpose would be 1, -1, 2 and 3. Now if I were to substitute the value using K to be as pi, I would now get pi times of 1, -1, 2, 3. Rewriting, this could be written as pi, -pi, 2 pi and 3 pi, which is the left hand side. Clearly you can see that K times A, the old transpose, is the same as the answer that we have got for K times A transpose. A positive B transpose is equal to A transpose positive B transpose. So let us consider A to be as 1, negative 1, 1 and 2. Matrix B to be as 2, 3, 4, 5. Now let me start off with the left hand side. Consider the left hand side which has got A positive B, the whole transpose. So foremost, before we could obtain the transpose of the sum, let us start with A positive B. So A positive B would be 1, negative 1, 1, 2 added with the matrix B 2, 3, 4, 5. Now adding this would give us 1 added with 2 would give me 3. Negative 1 added with 3 would give me 2. 1 added with 4 would give me 5. 2 added with 5 would give me 7. So this is A positive B. So therefore taking the transpose for this would give me, the rows would become columns. So that would be 3, 2, 5, 7. Now let us consider the right hand side, which is A transpose plus B transpose. Now this in turn would be, clearly the transpose of A would give us, the rows would become columns. So that would mean we got 1, negative 1, 1 and 2. The transpose of B, the rows would become columns. So that would be 2, 3, 4, 5. Adding this would give us 1 plus 2, 3, 4 plus 1, 5. Negative 1 added with 3 would give me 2. Right. So comparing left hand side, comparing right hand side with that of the left hand side, we can clearly see that they are both equal. We are going to be checking property number 4, which is AB, the whole transpose, would give us B transpose times A transpose. Now, let us take the matrix for A as 1, 1, negative 1 and 1, and matrix for B to be as 1, 0, 2, 1. Let us perform the operation AB. AB would be equal to, matrix A is 1, 1, negative 1 and 1. That has to be multiplied with matrix B, which is 1, 0, 2, 1. So multiplying the row with the column would give me 1 times 1 positive 2 times 1, that's 2. Similarly, multiplying the second row with the column, negative 1 times 1 positive 2, and following it up would give me 0 positive 1 and 0 positive 1, which in turn would be 3, 1, 1 and 1. So taking the transpose for this product would give me, the rows would become columns. So that would mean 3, 1, 1, 1. Now this is not the end of the question. We got some more to go. So now we are going to be working the right hand side. So to start off, consider the right hand side. Now if you were to take the transpose for the matrix B, the rows would become columns. So that is going to be 1, 0, 2, 1. That has to be multiplied with A transpose. Again, the rows would become columns. So that is going to be 1, 1, negative 1 and 1. Now, if you were to multiply them, the row with the column, that would give us, so 1 multiplied with 1, positive 2, and then following it up 0, the second row with the column, plus 1, negative 1 plus 2, 0 plus 1. Adding this would give us 3, 1, 1 and 1, which is nothing but the matrix that we have just obtained here. So this is equal to the left hand side.